Okay, we'll get started. So we have 1 full hour just before lunch, or maybe during our usual lunch time. So we'll see. We'll try and make it as interactive and as interesting as possible. I'm Kiru. I'm a consultant with ThoughtWorks. We are a technology consultant company, and we are in 4 cities in Australia, including Brisbane and Perth as well. So to start with, assuming that if you play a bingo game using all the buzzwords, right? Like pretty much everyone in the room will be a winner, within 5 minutes of a talk, in any talk in this conference. Because previously, if you used to see, things used to change, once in 10 years, once in 5 years. Now it's like pretty much things change every few months. And especially if you take things like Docker, so you have a major version released every 2 months. So whatever you learned, whatever you did 3 or 4 months back might be kind of changed now or become obsolete. So that is a kind of pace of how things change nowadays. And before we get into all the technical details and all that, let's start with a simple question. Kind of what's the feedback loop between your organization and your end users? So in the sense how comfortable are you with responding to their changing needs? So whatever changes we are talking about need not be really big. So it need not be totally a new set of cool feature you need to think about, develop, and give it to them. But very simple things like how do you respond to changes in the real-time events. A very simple example if your organization is supporting AFL, you're supporting a particular team, and they're playing a deciding match or semi-final match, and it's like the game went to an extra time, so you're in that second half of 5 minutes, and you have 18 goals each, so the game can go either way. But till your team is in the game, you need to react in a way, respond in a way, and depending on the game result, probably you may want to change something. So this is a very simple example, but depending on the type of business you do, depending on what you do, and based on the real-time events, you may want to react and do changes more quickly and frequently. So whatever we are talking about, yearly to market, putting things in customer hand, generating that value more frequently and repeatedly, it's not anything new for us, right? That's what we have been trying to achieve, for a few years now. So how did we start with it? So initially, we started with automation. So ages back, everything was manual, unpredictable. So we started with automation. And as we can clearly see that as we get better with automation, it had a clear impact on the speed of delivery. But sooner or later, you're going to hit a threshold point beyond which, how much ever you automate, you cannot go any fast. And there are a lot of reasons for that. And in most cases, one of the major underlying reasons is how the system is designed and how it is organized. Historically, this is how our applications look. So we have one single large system, and which will offer you as many business capabilities as possible. So even if you're offering XYZ, a different capability which is totally different to it, but still everything gets packed into one single IT system. And if I have to do a very small change, whether be it just single line of code, just a log statement, it is a part of my entire system. And for me to get it to production, I need to basically deploy my entire system to my production. So historically, that is how we have been doing. But in the recent few years, we are moving away from that monolith, one large application, into more towards fine-grained architecture, more of microservices architecture. So today, we can compare our system to something like this, where you have multiple components, and each component might deliver a subset of features, or in the best case, probably one single business capability. So it does only one thing or very few things, but does it well. So the very first glance, if you look at it, it looks as if everything is so easy to do, very seamless. They all talk to each other so nicely, so I can just break it down, improve my cycle time, make things faster. But actually, whatever these are features, right? Most of those features are, the characteristics of the single application. So if you have one single application, It's basically easy to manage. It's easy to debug. It's easy to deploy compared to us have been managing 10 or 20 different components. So even if you go back and refer to the definition of fine-grained architecture, right, or a definition of microservices, there are n number of definitions. There is no one legal definition for that, but the one I like the most is like how Sam defines it. It's like small autonomous services that could be that work well together, and also which could be deployed independently. So though you have 10 or 20 different components, unless you have a good deployment where you can, each has its own life cycle, where you can deploy each independent of others, until we reach to that maturity level, it's not going to actually give us any benefit. So why is it different? So deployment is not anything new for us, right? Like we have been doing it for many years now. So basically, we should be good in that. So we learned a lot of lessons over years. So ideally, we should be good in what we're doing. So the main difference now is previously we had like one application, or at the max like we had like 3 or 4 different applications. So probably you may have a big database component, and you have a couple of web components, and you may have your app layer. So we had kind of dedicated environment for them to be deployed and run. So even the days when we moved to cloud, but they had an isolated operating environment. So take, for example, in this server, whether be it a physical server or a VM machine or somewhere on the cloud, but when I try and deploy this particular component, I have an isolated operating environment for that component. So nothing else gets in the way. But the moment we try to deploy multiple components onto one single server, what happens is like kind of, you might end up with conflicting dependencies. So you may have like 2 different components. One is still in Ruby 1.9 for some reason. The other one is moved ahead, something new which I started yesterday. So I started on 2.x something, and they're conflicting. And especially if you are in a large enterprise-like world where you have like Java coexisting, and you're starting with Angular and you're starting with something else, you want to try out something functional, I'm pretty sure you'll have something on Java 6 and Java 7 and Java 8. So you might end up with conflicting dependencies on one single server. And what else can happen? Say, for example, you get an alert from a machine. So how do you debug that? How do you know what's the reason for it? What's the root cause? So you need to look at all 3 components for that. And what if one of my component ends up using all my resources on that server? So it's kind of denial of service for everything else deployed on that server. So all that we are trying to think about is like, I want my component to be deployed to be treated as a black box. I want to bundle everything, whatever is required during runtime into the black box. I'll just give it to any environment to be deployed, whether it is on my dev machine, whether it is on my test machine, or whether it's on production. I just want that particular component to behave exactly the same way. And all that I really worry about is, how do I reach that component? How do I talk to it? If it's a service, what's the contract? Or if it's a database, like, okay, what's the entry point for that? Kind of, does it all sound familiar to VMs? So, there are a couple of reasons to start using VMs, but one of the few reasons is like, I want my dev environment to look exactly similar to my test, or I want to replicate those environment, in my, on my dev machine, and I want the isolation between the components. How many of us are like using VMs in some form or the other, either on dev or prod? A lot of us. But we all know, what happens. Like, say, this is how we started. Before using a VM, so have your hardware, and you have the OS, nothing but a special piece of software, and you have like components directly deployed on that. And then we started with VMs. So it introduces a layer of hypervisor. Hypervisor is nothing but another special piece of software. It just depends on which vendor you choose to use. And all that it does is it abstracts the underlying hardware from the OS. So it takes away all the hardware-specific devices and drivers and everything. So that gives us an opportunity to introduce any operating system independent of what's your host. And then I can deploy my app in the VM. So over here, you get that complete level of isolation. So the app 1 is completely isolated from app 2. But we all know the demerits of VM, right? So, I can, if I try and do a demo, so I might, at the max, I can run 4 or 5 different VMs. That's it. And, if you have worked on VMs on your local machine, you know how large they grow once you start using them. And if you're someone like me who never shuts down your machine, it just, keeps running and it just, grows to, gigabytes. So what's the other alternative? So the other way is like kind of, using a container. And again, Docker is just one way of a container. Docker doesn't mean that it's a container. And so in this case, like we need a Linux operating system. So we'll come back to that and see why we need Linux OS as of today. And then you can have a Docker daemon running. And if you have a Docker daemon, you can deploy multiple containers on that. And very similar to VMs, how you get an isolation between the VMs, you get some level of isolation between the containers deployed on the same machine. So we'll go a little bit deeper into understanding how we get that level of isolation. But for you to go back, so if you want to go back and try something, do a spike using Docker or use it in your project, so you don't have to know anything about it. You will not end up changing anything in these. But I feel as a dev, it gives a satisfaction to have an understanding of how things work underneath. So in the previous one, we saw that there is a hardcore dependency on the Linux OS. So for me to run Docker, so even if I have to run Docker on my Mac machine or on Windows, so I need to have a layer of Linux underneath. So I might end up using a VM machine, so a Linux VM. On top of that, I might install Docker and run. So why is there a dependency on Linux here? Because you get that isolation, you get those isolation between the containers using the capabilities from the Linux kernel. So it makes use of combination of CGROUPS, namespaces, and the copy on write storage. So it makes use of these capabilities which is offered by the Linux kernel to give us that isolation between the containers. So just a very quick look at understanding what these terms mean and how it actually helps us. So the first one is cgroup. Cgroup, it helps us to limit the resource usage. So if you remember previously we spoke about if I deploy multiple components, like what if one component ends up using all my resources? So it ends up using all the memory. So the other components deployed on the same host cannot run. So you can use the concept of cgroups and you define this particular group of process can use only this much resources. Say for example, so the way it works is it maintains a tree hierarchy structure for process. So the moment we start our machine, so it starts the init process or init or systemd, depending on whatever kernel we use, and you get a PID1, process 1. And by default, it is allocated to the default group. And the default rules, whatever you specify, will apply to this group. So whatever process we create after that will fall under the default group. And under this, you can also create different groups. So under memory, I can say, OK, I need a special memory. This particular set of process will never need so much memory. So allocate less memory for this. Or probably you may have a different set of process, DB. So these need more I/O. Allocate more I/O for this set of process. So you can create different groups. And you can associate n number of processes under these groups. And for each group, you can define different set of constraints and different set of rules. And that is how you can get that isolation. You can ensure that the resources are available for multiple containers running on one single host. And going to the next one, namespaces. This is one of the most interesting one from the Linux kernel, where using namespaces, you can actually define a very limited view of the underlying kernel. So in case of VM, what happens is every VM has a complete OS replicated again. But in case of container, basically, it reuses the underlying, Linux kernel. So what you can say is this set of, process can see only, row 1. And a different set of process can see only the, last row. And a different set of process can see only that corner of the room. So you say that these processes can see only this much. So for those processes, OK, that is the entire amount of resources available. So if I don't even know that the last row exists, so for me, trying to misuse that or use that resource is, impossible. And in this case, the resources could be, your networking, your ports, your user, and your, build, and your mount, your devices. So whatever you can think of as a resource in a machine. So pretty much for all those resources, you can create this underlying constrained view. So very similar to what we saw in CGROUPS. So even here, it maintains a kind of a hierarchy structure, and then you can associate different rules. So by default, everything is under the default group, and this is kind of applicable even in case of Docker. So when you start a container, what Docker does underneath is it creates a different namespace for that container. So okay, container 1 is started, so it has its own namespace. So whatever process is created under container 1 sits under this. So this is the entire world for container 1. So according to container 1, there are only 2 processes. I'm PID1, and I have another process 1008 running along with me. That's it. And this PID1, if someone from the host machine is looking at it, it will not be PID1. So it will be a process ID with a different number. So this is privileged and only within container. So kind of that similar to very recently we had a user namespace introduced as well. So in the initial few versions we didn't have a proper namespace for user. So if you create a root user in a container, and even on the host machine it used to be a root. But now what you can do is you can create a root user just within container, and if that user escapes, or if you try to use that user on a host machine or from a different container, it's just a normal user. So again, similar to that, you can create n number of containers. And again, every container will have its own PID1, and if it leaks or escapes on the host machine, it's a normal process. And coming to the last one, so we spoke about CGROUPS, which will help us to limit the resource usage. And then we saw namespaces where you can say this is what is the resources. And the next one is copy on write storage. So we all know how long does it take for us to start a VM. So even if you have an image, even if it is like compressed and everything, but it does take a couple of minutes for us to start a VM. But compared to that, if I have to start a container, it's like really quick and pretty fast. So how does it happen? So it makes use of something called a copy on write storage. So we know that you can create a container on my local machine and take that and replicate it on any higher environment, or just share it with my colleague. So the way it works is for a container, the container is started based on an image. So the image is nothing but a template for a container. So it's very similar to how you have a VM box image, or if you're on AWS, you'll have an AMI. So it's basically a template. And this image can be created from the Docker file. So Docker file is nothing but a set of instructions. And you say, okay, what gets into that image? And every step which is defined in Docker file gets translated into a layer in the image. Say, for example, you can start an image either from the scratch, where you don't have anything, or you can start an image based on an existing one. So I can start something based on Node.js, and then I'll build something on top of it. So either it could be a scratch, or it could be based on an existing image, and then you can have a set of instructions. So these instructions will tell you what gets into that image. So you can install a couple of things, copy the files you need to, or export certain ports you want to. So you can do whatever is required for the app to run. So I'll just pick a simple example. So this is just adding some metadata saying who is the maintainer for this image. So in this case, it doesn't add any bytes to it. And then you say that you're updating something and installing Nginx, and it's adding as a layer here. And every layer it adds is going to be just read-only. So what happens, I install Nginx here, and in the very next line, I go ahead and remove Nginx. So all that it does is it will add another layer and say remove Nginx. So it doesn't go back and rewrite what is already written. So all that we get is, based on the Docker file, you get a layer of read-only images. So that's how these images could be reused between containers. So you can expose a particular port here, and then you say what's the entry point. So when someone is trying to start a container, what is the entry point for this container? And if you're trying to scale, right? So I have an Nginx, so I have a Docker image created for Nginx, and I started a container. So when you say started a container, already you pull down that image. So you have that image on your local machine. So what if I want to start 10 containers instead of 1? Already you have the image in here. So for starting the other 9 containers, exactly same copy. It doesn't download anything new. So it just uses the same image and starts whatever n number of containers. So it's pretty fast. So everything is a read-only layer. So the way it does is, based on the content of each layer, it just creates a hash. So based on the hash, you know what is that. And if you have a different, say, if you have creating a different one for Angular, if you're a different image for your app, and one of the commands in that stays install nginx, so it will not do anything new. So it will just reuse exactly the same layer. So it will just refer to that same layer. And what happens when we start a container? So we are told, okay, it's a read-only, it's a read-only a layer. So when I start a container based on a given image, and it adds a very thin writable layer, just specific for that container, and whatever process we start will be within this container. So when we say start a container, so it creates a namespace, it creates the C group, and then it starts the process. So all that process is visible only within this namespace. And the moment you stop your container, whatever you write in this layer, whatever process you started in this layer disappears. And as you can see here, the underlying kernel is shared between containers, on a contrast to VM, where for every VM you'll have complete OS bundled with it. So when in the container, this entire slot is going to be just read-only layer, and only this specific one is going to be write. Whatever write, a file system is specific to, the file system will live only, when the container is running. So the moment you stop your container, your file system disappears. So this is a typical slide. So pretty much, if you go through any Docker, 101 or Docker intro, slide, you'll not miss this. So they say that, okay, if I have a VM, I have my app. So what if I want to run exactly, 2 copies of my app? So I need to end up replicating my guest OS completely, copy all my libs, and then copy all the files required for my app. So pretty much you have to replicate the entire stack in case of VM. But in case of container, you don't need an OS. You can just use the underlying kernel. It reuses it. And very first time when you try to run something, it downloads the image, which will have all your libs and all your files for your app. When you try to run exactly the same copy, the underlying image is reused. Only the container write layer is replicated for container 2. And when there are slight changes, so only those changes are replicated here. So this is what we see in a slide. So underlying, that's how it works. That's how you get that reuse between containers. Any questions still here? Or is it too technical? Should we go a bit fast? No. Yeah. Okay. So this again similar. So coming back to a problem, whatever we are trying to solve, okay, I have multiple things to deploy. I need to make it easier. I need to treat my deployable component as a black box. The way I deploy on my dev machine should be exactly same as what I deploy on my CI or the test environment. So Docker actually makes it much easier. Though you can achieve something similar using other different technology and all that, but it just makes the whole workflow very seamless. So in case of a developer, I just need to worry about what gets into a container. So what's my language, what's my framework, what are the files required, what's the data required. And for the deployment, all that I need to worry about is, for me, all the containers are going to behave exactly the same way. And I can worry about how do I network, how do I enable the containers to talk to each other, how do I enable logging, how do I get data out of the container. If something goes wrong, if a container dies, how do I get the information out of container. So you can clearly see two distinct responsibilities if you're going with Docker. So till now, everything sounds cool. So most of us would have heard about Docker in some form or the other. You tried it, gone through the 101 slides, we know the basic commands. So in most of our cases, you come to a point where you think about, everything is good, but where do we actually use it? Not in all projects, not in all companies, you'll have a ground where you can just go ahead and Dockerize an app and start using it on day one. Probably you might be in a scenario where I just know a little bit about it. I know a lot of people are using it, but I would like to learn more about it. But I'm not in a position to go today and rationalize something, change one of my app. Or probably it could be a Windows shop, where it's really, at least as of now, it's not, I don't have great support. But where else can I use it? How do I learn more about it? So there are lots of use cases. Other than just going ahead and Dockerizing an existing application, There are lots of different things we have done it within Docker in different projects. So what I thought is in the next 40 minutes or so, we'll just pick few examples where other than just Dockerizing an existing application, where else Docker could be used. Maybe we'll just start with a typical workflow. So this is what generally they say you can use Docker for. So you can use Docker for building your app as a Docker image. So that gives you the template. And then you can ship it. So it's basically just store that image somewhere centrally so that you can access it in the other environment. And you can run it. So based on the image you created and you shipped, you can run container based on that image. And it could be for any application, because the only dependency you have is you have the underlying Linux kernel. So if it's a Linux machine, you can run it straightforward, just install Docker and run it. Or if it's a different OS, if it's a Mac or if it's a Windows, you just need to have a Linux VM on that, install Docker, and then you can run exactly the same container. And you can run anywhere where you can install Docker. A typical workflow looks something like this. So you have your code repository, everything is checked in, and you have a CI server. Along with your code repository specific to that project, you're going to have a Docker file, which will tell you how to create the image for that particular application. So based on the instructions from the Docker file, you're going to build an image and do all the testing and package it, and then push that Docker image to a registry. So this not necessarily be a Docker registry. It could be any repository you're already using. It could be Nexus Pro, or it could be Artifactory, or whatever you're using as of today. And then when you try to deploy it in production, you can search for the particular image, again, just based on the name and the tag, and pull down that image. So once you have one copy of that image, you can run n number of containers based on that image. So this is the typical workflow if you want to Dockerize an application. But in most of, because me being a consultant, right, like kind of I get to see different projects, different clients, and different, their needs are different. So this may not be the need for everyone at a given point in time. So what else can I use Docker for? So let me start with one of my most favorite thing. So setting up my local dev environment. So at least for me, it's like kind of interesting because you never know what's the span of your project. So for me, few projects have been like a year or two, and then few months. And in few cases, it's like just few weeks and few days. So if I'm in a place just for a week, and they call me to evaluate something and give some feedback, and if I'm not able to run that application on my local machine on day one, kind of there's no value. It's like so daunting. You feel like you don't have a lot of freedom to play with. And every time I try to set up something, install something, you'll always have like one very last thing to do. And in most cases, that will not be the last thing. So if you try simple things like, you saw a cool dashboard. Especially it happens with the dashboard for me. I don't know why. For some reason, because I'm not a UI person, so I just try to copy from other people. So you see something on open source, you just download, consciously and unconsciously, my mind does a git clone. And you try to run it, and you tweak something, change config, get it working, and then you're like so happy. Go and show it to people on Monday, and they're like, yeah, it's really cool. Let's use it in our project, put it on our build dashboard, put it on CI. Then you realize, OK, I have no idea how I got it working. I just have it working, that's it. So there are a lot of problems like this, even things like, has anyone tried installing Ansible on a Windows machine? No? OK. Okay. Was it easy? Good? No? Yeah, I know. Because for Ansible, like, I ended up, started with Ansible, and then it needed Python. And then just not Python, it needed a specific, package manager for Python. So I need to go behind PIP, and then like it just went on and on and on. So it gets into that, vicious cycle of where you try to fix something, and then you see a weird error, and then you ask Google, and then ask Stack Overflow, fix it. It just gets into that, cycle. So in most of the cases, what helped us is creating a Docker, image for the local development. So this could be specific to project, or common to a domain or your org. It again depends. how different is your projects, how different is the technology, what is the need. So all that you need to do is like create an image, put things, install whatever you need. So if someone is new is coming, so just tell them install Docker. The only thing you need to install is Docker. Install it, start a container, start doing work. So if you go through like how we used to like do it, like okay, ages back we tried on documenting it. I'm pretty sure the very next day it will become obsolete. And then you try some wrapper scripts around it, put some shell. It's okay to some extent if it is just within a small project, it still works, but not if people are changing so frequently, right? Or if something is a long-lived thing, if it is just not specific to dev, probably you might end up picking a config tool. But again, like I don't know, it depends. Sometimes it becomes an overhead actually. Or pack things into a VM. Again, you have all those constraints like, and again, like most of the VMs we did were managed through Vagrant. Vagrant again underlying is Ruby. There'll be a lot of bad people like me who will go ahead and change something in Ruby, and then I'll have a different version. There'll be a lot of parity and stuff. Or run it as a container. And I'm not going to get into the details of how to do it, but that's like really easy. If you just go and search in Google, create a Docker file, create an image, create a container, you have plenty of tutorial to get it. So I'm not getting into the details of how to do it, but this is more about just creating an awareness, creating an idea about, just thought provoking about, okay, where else can I actually use it? But rather I thought I'll just share some of the lessons learned in my experience. So initially when I started, okay, my dev machine is Mac, so I had to run a Linux VM for me to install Docker. So I ended up using VirtualBox VM because it's free, and that's what I have been using.
Runs natively now.
Yeah, for now it runs, but like, yeah, I started with that. And then it's like, the default share was VBoxFS. So even the current one, internally it uses VBoxFS share. And when you try to mount files, from your local machine onto, the container, it's really, really slow. So there are a lot of other options. So even in the existing one, even if you install it native, internally it uses the Ubuntu Docker VM, where you can actually play with what amount you want to use. So try different things like NFS share, Unison, Samba, and finally rsync worked the best. So that was more seamless and it was really quick. I felt it more like a dev environment. For me, it's like I do some changes, I need to see that instantly. Otherwise, it's not my dev. And the other thing is, in few cases, actually, the build tools were broken. Most of these tools actually actively watch for changes in the files, and most of these depend on the very OS-specific technology. So it might depend on iNotify in case of Linux or FS events in case of Mac. I'm not sure about Windows how it works. So most of these tools actually depend on those technologies to know if something has changed or not. So sometimes, depending on what share you use and how you mount your files, this might be broken. So just ensure, when you're starting with the dev, be careful about what mount you use, and ensure, whatever build tools you're using, none of that is broken. And interestingly, this one, third one, so what we were trying to do is, whatever dev environment setup we had, pretty much we are trying to translate it into Docker container. So whatever I had, I just wanted to get into a Docker container and get it up and running. And then interestingly, someone in the team asked, okay, why am I using H2? So one of the projects actually in test, and in production we were using MySQL Server and like a lot of tons of data. But whereas in local and in CI and the initial unit test and the functional test, we were using H2 database because it's quick, fast, easy, everything is in memory. And then we just ended up using H2, even in this setup, for almost a few months. And then we realized, okay, now it's not really so difficult to run a MySQL database on a local machine. I can spin up whenever I want. I can shut it down whenever I want. So why not just move from H2 to MySQL on the dev and try? And we tried that, and it really worked. It's actually good, very seamless. So even in your cases, start with something simple. Typically we'll try replicating what we have into container and see how it works. But again, put a pause, give a thought. Is this what exactly I want to do? Is there anything I can do? So the main aim is try and get your dev environment as close as possible to your production. And the next thing is moving on. So okay, dev is one thing. So where else can I use? the next very good golden opportunity is to put it on CI. So you'll be using some or other tool for your CI. So why not run your CI server and the agent as Docker container? And in few cases, not necessarily the server. So you can leave the server as is, you can leave the database as is. But potentially you can run your the CI agents as Docker container. So the main advantage of that is like it's very seamless. It's very easy to scale it. So you can just start run n number of agents because you can run n number of containers on a single machine. So you don't have the constraint there. Or in few cases like in few projects like we had a very traditional centralized CI, and they were breaking down the path and going more towards where the CI is owned and managed by the team or the domain. So in those cases, we felt like it was really easy to do it with Docker, or when things are internally deployed on cloud. Especially if when you put things on cloud, you want to ensure that because in few cases we don't really give too much attention to our CI servers, right? As much as we give for our actual application servers. So what if this becomes your surface of attack? So how do you ensure that whatever you put on cloud is all sane and good? So it's easy to do it with Docker again. So you can have a base image. So the base image could be created and maintained, managed by some central team or someone who's responsible for that, who will actively look for security patches, ensure that all the OS security considerations are in place. And the teams can just go ahead and create images based on the base image, add whatever you want, install your stuff, add more resources, which is required to build your tools, and then extend on top of it. And the next thing, how many of you have heard this statement? Okay, the tests, I'm pretty sure, I'm pretty confident that tests are working on my machine. It's broken only on CI. It's because something else is broken on CI. It happens very often, right? We ended up again, the costs of those failures are different. So in few cases, you might want to build something, or you might be missing a tool which is required to build it, or some test components are missing, or even cases like your environment is not clean. Probably the previous build, which is failed halfway through, left something, something like that. So it is really good because the environment required for building, testing, packaging, and publishing are very different. And what we are trying to do is do everything on a single agent. So you can have an isolated environment. If it is a build, run it within this container. If it's a test, run it within this container. And even if something happens, only the container will blow away. Only you can clean that container, but still your underlying machine, your agent will still be fine. You can avoid using your CI as a test field. So what I mean by that is, in one project, we were using Cucumber for functional test. And not everyone in the team is very hands-on with Cucumber, so it's very new for them. And we had a small subset in the team who were very excited about it, adding more tests, adding more stuff. And they were the only ones who were actually doing development. The other ones were copy-pasting the code and changing what is required. So it happens always. So the majority of the team did not have Cucumber set up, installed on their local machine to run. So every time they change something, they'll do it is, OK, pray God and push the button and just run it on CI. Just hope that it will be green. So if it is red, I have no means to replicate it on my dev. I'll just go through this again, try my luck again, change again, and again push it. So if you have a context to run, I know that within this container, I know the Cucumber test for this project can run. So it's very easy to start that container either on a CI machine or on your local run the test. So you'll not end up spending more time on understanding tools and learning different tools, but rather you can focus more on your application and have these things ready-made. And last cool thing, which we are doing it in my current project, is no wait time for any of the builds. So it's we have tons of projects, and the way it works is one particular project kicks in a build, and that is kind of a ripple effect. So that will start another triggered 10 different pipelines, and they'll occupy all the agents, and everybody else in the queue has to wait forever. So what we wanted to do is, depending on what job is in place, I want to create an agent, I want to run it, and once the job is done, I want the agent to be removed. So we started adding tags to the jobs. So every job will have a tag. So these tags will tell you what are the resources required. So I may need a Gradle, or I may need Java, I may need Ruby, Cucumber. So we have predefined tags. So when you submit a job, so the job will have the tags defined. Based on these tags, I can dynamically create a container with all those resources in place. So I can create a container and say this is the agent, and then the job will be scheduled. You can run the job, and then once the container becomes idle, it's very easy to actually remove them. So pretty much we don't have agents up and running. So we used to have like a lot of heated debate. What should be our scale? Should I be running 10 agents? Should I be running 20 agents? How do I scale it? Or should I be starting something at 8 a.m. and finishing at 5 p.m.? Like you used to have all that debate, like what is the right amount of scale for the team? But this becomes like more dynamic and more real time. So when there is a need, when there is a job waiting in the queue, create a corresponding agent, run stuff there, and then stop it. So this you can do for any project. Say if your project is old school, so you for some reason know that this is not the right time to change stuff, or other things are burning, I don't want to touch anything in my project, or it's a Microsoft thing, .NET thing, I don't know how well it is supported as of now. But these are the things you can pretty much do for any language and any framework. And the next one, so we can do dev environment, and you can do a lot of cool stuff on CI. Where else can I use Docker other than for my application? So the other big thing is we have used in a lot of places for testing, making testing easy, making it accessible and stuff. So before getting into those stories, maybe I just want to have a real quick look at one of these surveys done in the testing community. So this is just to understand, if at all they hesitate to test, if they don't want to write test, when will be that scenario? They want to understand these scenarios so that they can try and address them. So as you can see here, a staggering 47% of people felt they'll hesitate to write test, or they'll hesitate to add more tests if they know for sure that it's going to slow down their deployment. So if it is going to add time to their deployment cycle. And also the other related quadrant is 34%, when they feel that, okay, whatever I'm going to do is going to slow down my test, or if it's going to make things very difficult to set up, then I'll be hesitant to add more tests. So pretty much all that. How many of you have nightly builds which will go ahead and clean everything, write a clean slate for you, and make stuff? I don't know, for some reason, I don't want to do that, but I end up doing that. So pretty much I want that clean slate to be there before my every test run, but it's so damn slow that you can't do it every time. So we have nightly build schedule. So the main reason behind that is you don't have an isolated environment to run your test. So that is why that's kind of a symptom. So the actual root cause is you don't have a clean environment because you don't have an isolated environment to run, and we end up cleaning it, but rather try and address it the other way around. What do I do to give you that isolated environment? So try and play around with that idea. Maybe you'll come up with something different. I thought I will share some lessons learned in this space, some different approaches we tried and what worked well, and just pros and cons. So this is more for testing and application. So I'll have code. So you have code, and you'll have a Docker file for that along with that repository. And we'll have all the testing sitting along with the code. So you have all that in a single repository. And then everything is triggered in a CI. So it compiles the code and does all the testing. And then you generate the Docker image. And this Docker image step actually consumes whatever is generated in this build. So this could be, I don't know, an RPM file, or it could be a jar file. So whatever it is which generated during your build. So this particular step just consumes it, and then it deploys. Pretty much in most of my project, this has been the default approach, or this is the very first name approach, because it's easy to do. It makes sense. I have testing. I can deploy something as Docker. So I'm pretty confident of what I'm doing. But the major disadvantages, over time, what I saw is you have too much of intelligence built into your CI. So it's not that easy to actually separate your build process completely from your package. So you're seeing these as two different things. And if something goes wrong in this approach, it's very difficult to replicate that on my dev machine because I don't know why exactly it went wrong. But actually easy to do. If someone is totally new, you just want to do an example, you just want to showcase it, then this is a very naive approach and easy to get started. And what's the other approach? Like very similar to that, here again you have the code, Docker file sitting along with it and your test code, and you have the CI server, and then you generate one single artifact and then run test within that. So you might end up having your artifacts here and then whatever is required for your testing. So when we say artifact for the app, it includes the binaries for that application, whatever is built, and it will also include whatever is the runtime configuration required for it to run the app later. But this is kind of very obvious, right? You don't want to do that. So you don't want to include all your test components onto your artifact, which will eventually be deployed in production. It's very bloated and it's not the right way to do it. It's like very obvious and evident. But this is one thing like we tried in a few of our projects, and initially we felt like for testing it made things easier. So it was easy to test. So we're pretty confident. But comparing this with the previous use case, so the main problem here is, though the pipeline was green, in few cases actually the app did not work. The main reason behind all testing was done only whatever is, say, jar file created here or RPM, NPM created here, and then you create a Docker kind of image based on that. And that is something which is not tested, which is not in your test process. So if something goes wrong in that step, you'll never know. Your app will not work, whereas your pipeline will all be shiny and green. So this will give you that test confidence, but again, it's bloated. Like you don't want to, though the size of the image is much lesser compared to VM or whatever it is, but still it's bloated and you don't want to do that. And the third approach, which we spent a lot of time in understanding and figuring out different means, is the first thing is create your deployable artifact. So very similar to that, using this, I'll create a Docker image and I'll have all the artifact required to run it. So I'll have my binaries, I'll have my config, everything to run it, and then generate a different image just for test. So based on this Docker image, have the instructions to generate a different image. So this will become the base image for my test, and then only on this image I'll include all my test artifacts. So I'll include, say, Cucumber, or I'll include whatever different tools I want to run it, and then I'll include the runtime. So only for test I need Ruby because it's a Java app or .NET app. I know I do not need Ruby in my actual application, but whereas I have some BDD test written which needs Ruby to run, so I'll include Ruby only in this image, or include the test data, runtime configuration only for testing, include all that in this particular image, and then run your test, and then you'll be more confident to deploy. Somehow I feel if you remember that typical workflow for Docker, right? Generally people say build, ship, and run. Personally, I feel that we should change that a little bit. We should start seeing it as build, test, ship, and then run. Because testing is a very big aspect. In most of my projects where I tried Docker, like we literally forget about it. Like we do test, like test for the application, we do it. But it slightly changes the course of your deployment. You don't really think too much about that initially. And especially if you're using Docker version 1.11 or 12, and you have instructions in Docker file where you can use on build. So where it says, okay, on build, like after the image is created, you can do different stuff. So you can use that on build command to say that, okay, only for test, and the build time add a lot of different stuff, only for testing. And I have some examples in place. If someone is actually working on this, if you need working examples or more information about this, I can help you with. And generally, Docker is useful only if you're deploying multiple components. Say, if you have one single app which is not going to change forever, or at least you don't have a very frequent release cycle, you don't have a release cadence, you just deploy it once in 3 months and just 2 or 3 different applications, then using all this is just an overhead. Actually, it's not really worth the effort. But if you have like a lot of services, it's more fine-grained, I have multiple components to be deployed at different scale, different life cycle, then it makes more sense. But once you have that right, like your integration test becomes more trickier. Because in most of the cases, your integration test is like nowhere closer to what production does or how the production looks. So if you use a container, again, setting up that environment on your integration test is much easier. So even without Docker, it's easy to have an automated pipeline. You can do unit testing, you can do contract testing, and you can do even mini integration just between few components. But in most of the cases, there'll be a need to have a long-lived test. Like you may want to do performance, or you may want to do stress test, or all of us know about Chaos Monkey. I want to do that here. I want to see how it works, how it runs. So you need a long-running environment to do all that fun stuff. So using Docker, again, it's like very easy to get that set up and running. And now you also have like a default scheduling orchestration mechanism with Docker Swarm. It's like very easy to even set up that networking and set up that structure very similar to what we have in production. So in testing benefits, already we spoke pretty much about it. It's easy to scale stuff, so you can do that scalability testing, run thousands of components on a single machine. Easy to do load testing, and again, it's easy to have a Phoenix testing environment, so your testing environment is not polluted. So every time you start your test, you'll have a clean state to start with and no nightly builds. Okay, how many of you feel confident? Okay, if I have all this stuff, like okay, I'll be really confident to press a button and deploy stuff. No? Of course, there are always a lot of things to do. One thing I missed, we missed most of, during the initial adoption of Docker is like having a test-driven approach for the Docker image creation or the infrastructure creation. Has anyone heard about server spec? Like, yeah, server spec kitchen, yeah. So where we try and automate our infrastructure through code. So instead of manually creating something, I'll have a set of code, a configuration using which you'll create your infrastructure. But how do you ensure that whatever infrastructure I create is good, is exactly what I define? So this is more like a test-driven approach for infrastructure code itself. And a lot of different tools, and one of the tools which supports Docker or works well with Docker based on what I know is server spec. And this is a async, aspect-based testing framework. It's pretty easy to use, easy to understand. So you can do testing like, say in your Docker file, you say copy this file or copy this command, install this software. So install Nginx, install Go. So you can write test, okay, whether this package Go is actually installed in this image. And also, based on the image, you can create a test container. During a test process, you'll just start a container, run your test, and stop the container. So you can start a container and say if you're creating a Docker container for Grafana, where you can say that, okay, I'm expecting a service, Grafana server, to be up and running. Or if it's an application, you can say I'm expecting app1 to be up and running, and it should be under this particular user. So you can do like a lot of different stuff. It's very easy. It's easy to do. It's like, the syntax is pretty simple. It's like, if you know Ruby, it is like pretty much straightforward. So my lessons learned is like, don't think it's a hard thing to do. Don't think it's like an afterthought. Okay, after I have my first app running, I'll add test. Actually, it's pretty easy to do. When you start with your very first one, start with this mindset and approach. And the other thing, like where I pretty much unconsciously ended up using it is in most of my demos. So I feel like it might help to trigger that innovation culture in a large company. So if someone is traditionally, I have done Java for, I work with people who is like so damn good in Java. They just know in and out. It's like, but they're a little bit hesitant to try something new. So if I talk about Ruby, do Ruby, they're like a little bit hesitant. It's like, no, I'm so comfortable in this world. Like, I don't want to come there. So, if you just want to try something new, like you don't want to end up messing, on your machine, just want or play with an existing, application or a little app dashboard. So it's like very easy to actually, share it with people. And if you're thinking about or planning for, a Docker adaptation, or any adaptation for that matter, So what I would suggest is like have a plan, have a thought. So like we saw in our examples, like we didn't really talk about Dockerizing any application. We just spoke about a lot of other different use cases. So similar to that, like you might have a lot of other different problems. So when you're starting with something, using a cool app is one thing, but that's not actually directly translating to benefit, or it's very difficult to communicate why you're trying to use something. So when you're starting with something, like have a plan, like just a thought about, okay, this is the problem, this is what I'm trying to solve, this is why I'm using this particular technology. And when you're doing something, like do it end to end. So when I say end to end, when you do something, run things on CI, put things into production. So most of my initial things where everything's like sat in my dev mission or just within our team. It never really went into the actual application or into production. So when you do your very first thing, do it end to end, put things in production, run it on CI. So that will give you a different set of learnings altogether. While, yeah, really actually. Okay, this we did in one of the hackathons recently. So we used to use, we use a lot of custom, build lights. So everybody used to bring in different, boards, and we used to try, different things. It's more like a competition between us and the team. So we used like a Raspberry Pi, and is there anyone like who used it? Like, yes. So if you like use it, it's pretty cool. So every time you do it, like you have like you envision very big, like so you have lots of ideas. I want to connect these things in my home, do that stuff and all that. But every time you do a development in that, like it's like pain to deploy something. So other good news is you can run Docker containers on a Raspberry Pi. The only thing is like I mean it's Linux based again, but it's not AMD or Intel, but it's ARM. So only thing is you need to package your app slightly different. So people have already done all the hard work. So you just go search for it. You have a lot of RPA based images in Docker Hub. So you just need to download that image, add your little code, and just run it. So it's really easy. You'll love it actually. And again, just to close with, so anything we do has a strong foundation on continuous delivery. So whatever work you do, just because you do services, just because you do microservices, you use a different app or a technology, doesn't mean that you're going to go any faster. And the same rule like applies for Docker as well. Just because you're going to use container, you're going to use Docker, it's not going to make things any faster unless you have like strong foundation on continuous delivery. Cool. So just a recap of whatever we did. Like this is like pretty much the goal for IT forever. Like never changes. So we started doing continuous delivery, and then everybody is talking about microservices. Like that's one of the buzzwords in the bingo. And then you talk about you have a problem with deployment. Kind of Docker and microservices go hand in hand. So once you have a clear strategy for your deployments, you'll be more confident to adopt fine-grained architecture. And things change so fast. Like you learn about something today that will be bought by a different company, renamed to something else, rebranded to something else. You'll get it in a different flavor just in a month. So things change so much. So you may not be able to adopt everything, do include everything in your project, but at least it's good to have an idea about what's happening around. Cool. So I just took a slightly different approach today. Instead of going through technical stuff, I just want to talk about where you can use it. So feel free to share your feedback. So this is the first time I'm doing in a different style. So just let me know how it was, like how you felt, whether it was good, bad, whatever it is. Okay. Thank you.